All right, as for today, we're going to look over sampling and experiments. So we're going to start with sample surveys. With sample surveys, the biggest thing is identifying the couple of big pieces of information. And it's always easiest to start with the sample, generalize to the population, and then identify what you're calculating on the sample statistic, and then generalize that to the population parameter. There's going to be a lot of terminology here in this second material, in this set of material. So let's look at an example here. So let's start with a base sample of 2,000 US adults. This then generalizes to all US adults. Now, a quick note, people are always like, oh, the sample isn't big enough, that's not representative enough. Just a year or two, Gallup poll, right, which is the nation's leading statistical sample company, they did a study actually representing that 5,000 US adults, once you get to that number, you can't get any additional information. Actually, 5,000, all right? And so actually just to show that this is the best representative, let's say we took 5,000 US adults. 5,000 US adults has enough sampling variability to represent the entirety of the US. All right. Just for a note, how many people are in the US? Do we know? A lot, approximately. No idea? 330 million. All right. That's 5,000 is representative of that. All right. And so just so you know that a lot of times people are like, oh my God, the sample's not big enough, sample's not big enough. They showed that you can't get any more information past that unless you go all the way to a census. All right, we'll talk about that too. So 5,000 US adults representing all US adults. And that's the big thing here. This is representative. And that's a key word for us because representative means that there is no bias in the data, right? If it represents what you're looking for, then our sample is a good sample of our overall demographic we're trying to generalize to. And then, all right, so from those 5,000 US adults, we want to calculate something. Let's just stay simple. Let's say we want to calculate the average age of the 5,000 US adults. This then same thing, the population parameter generalizes to that value. So this would be the average age of all US adults. The sample statistic is then used to infer or make inferences, all right, about the general demographic. This number here, this 5,000, that's what we collect, right? You sample 5,000 people, you ask each one of them their age, all right? You calculate that number, and let's call it, I think, average age in the US. With the baby boomers still alive, it's got to be mid-30s, all right? So then we say, oh, all right, we can generalize. So if the average age is 35, then the average age of all US adults is 35. And that's basically the entire point of statistics. I was like, that's always what we're trying to do. We draw a sample to generalize to the population, we calculate something from that sample, a statistic, right? The class we're all in order to generalize to a population parameter, and parameter is just the general word for a sample statistic. And so back to my concept, bias is what we're trying to avoid, which is when we draw that sample, right? When I draw a sample of 5,000 US adults, do I draw them all from Wyoming? No, we try and get a representative of the entire US. Did we get this? Amen. So, as I was talking about, we need to randomize because, again, everything in statistics is about what's happening on average. Are people individuals? Absolutely. Okay. But statistics is about what's happening to the average person. All right. There's always, right, exceptions to the rule. And in statistics, what do we call those? When people are not close to the average. Outliers. All right. There's always outliers. That is the whole concept of data, okay? But we want to draw the conclusion that satisfies the largest amount, all right? Which is why we always look for the average. As I just said, right? Everyone's always worried it's the sample size. Actually, the problem usually comes in the opposite direction. If your sample is over 10% of the population, then you actually can be very problematic because you're drawing too much from a particular group, very likely. Now, as a note, statistics is all about taking samples. But if your entire population is only 2,000 of whatever, why not just do a census? Why not collect everybody? Because then there's no need to guess. There's no need to, oh, I take a sample that can't be up to 10% of the population, right? And then I make inferences. If you can collect everyone, collect everyone. And that's always, I mean, that would always be the goal. In the US, we try and do this as well. How often do we do a census in the US? Every 10 years. And for those who are unfamiliar, that every 10 years starts about 2 years before and that lasts 2 years after. It takes 4 years to try and count everybody. Now, here's the other thing. The census, the US Census in particular, is really problematic. All right, trying to count 330 plus million people. All right, there's lots of problems, but the two most common ones that have been around forever are geographical. What two geographical regions of the US is it hard to count people? Rural. Rural is a huge one, right? We live in one. All right, census takers are literally just people hired to go out and count. Right? Wyoming is a big concept. You're driving down the road. They get to the end of the road. It turns into a dirt road. They see 5 mailboxes. All right. Do they want to drive 50 miles down each road, or are they going to count the mailboxes and say, oh, I think there's about 2 people per mailbox? Right? So we're not getting accurate counts there. Okay. What's the opposite of rural? Urban. Urban, actually, and specifically densely urban. All right. When things are very, very densely urban, it's really hard to count people in dense urban dense urban areas. All right. Projects are one of the biggest ones. All right. Because again, census takers are minimum wage type employees, and it can be very dangerous. All right. In densely urban areas. So they avoid that and they estimate that. The point is that at some point, census just doesn't make sense. And God, I can't remember what the number is. It's like in the hundreds of billions of dollars that it costs to do the census. And they have to do statistics estimating all these various areas, let alone transient populations, right? All right, immigration is hard to count. Why are we still doing the census? We should use statistics to estimate. That's the whole point. Now, here's the other good news. Along those lines, if we were able to do a census every time perfectly, what would disappear? Statistics. So thank goodness the almighty dollar always has a role, because if we were able to count everybody every time for everything, there is no guessing involved. There is no all these techniques of estimation and calculating stuff, because you just know everything automatically. So thank goodness. All right, we can't do a census. We should just invest more in statistics. All right, so as I said, population parameters and sample statistics. We calculate the sample statistic to make an inference about a population parameter, and that's basically what we're going to do every time. There are several big techniques of simple random samples, of sampling methods. Simple random samples is by far the first, the foremost, the most common. This all comes down to the sampling frame. The sampling frame is about basically, you pick your demographics. So if I was talking about all US adults, that sampling frame is about getting that list of all US adults. And this is why this method is the most commonly approached, but the most commonly messed up, because getting that list of all US adults is very, very difficult. And so that's why we try and do these in smaller groups, and that's why we have other methods. But if you can get the proper sampling frame, then simple random sampling is the easiest. Let's say I got the list of 330. Okay, and actually, so 330 million Americans, which actually means there's like 270 million adults. So assume I got 270 million adults, all right? I got that giant list. Then the easiest thing is you put that list into a random number generator and it spits out 5,000 values, or the concept is you wrote everyone's name down, put it in a giant hat and pulled out 5,000 names. So simple random sampling, very, very common approach, all right? But getting that proper sampling frame, that's the problem with this, which is why we have other methods. One of the next best, most common method is stratified. Stratified breaks people into particular groups, right? Non-overlapping, AKA mutually exclusive, disjoint groups, and then samples from that group. So you basically break people into smaller categories and then sample from there. A common idea there would be like, if I'm sampling a high school, break people into freshman, sophomore, junior, senior, right? Can you be a freshman and a sophomore? No. So those are homogeneous, AKA non-overlapping type groups. And then I could sample, let's say there's 1,000 of each category. So then I go in and I sample 100 freshmen, 100 sophomores, 100 juniors, 100 seniors. And that also gives me additional data, because then I could compare, what's the average age of the freshmen versus the average age of the seniors? And so this is by far the next best method, all right? Because breaking things into smaller groups first and then sampling, you're less likely to miss your groups as well. So cluster sampling, very, very similar to stratified. But cluster also comes down to, it's usually a matter of cost and how available is it. So same, back to our university example, or let's transition that to university. So I have freshmen, sophomore, junior, seniors at a university. But instead of looking at freshmen, sophomore, junior, seniors and getting that, sampling them, maybe a dorm, all right, let's say the dorms go from freshmen to seniors, all right? A dorm is pretty representative of all the classes there. And if that is representative and there's like 30 dorms, I could pick a couple of dorms. And then those are overlapping groups, but they're still representative of the whole. And so cluster sampling can be very, very well done as well. And it's way more cost effective, because if you can look at a smaller area, this is more geographical, I can look at a smaller area and be like, this area is still representative of the whole population. So I could just sample from that area. And that's what cluster sampling is. So people sometimes struggle the difference. And basically, the easiest difference is that stratified sampling is non-overlapping groups. Cluster sampling is overlapping groups. And often it's about the cost. Because again, trying to find those 100 freshmen might be difficult. But, all right, trying to go sample one dorm, once you've knocked on that room in each of the dorm, all of the rooms in that dorm, you sampled that room. And both are good and can be very unbiased ways of sampling. Systematic sampling, also known as nth stage sampling, is about taking every 10th or 20th or 100th item or person. Actually, this is most often used in quality control. So items coming off a conveyor belt, right? So you're the quality control manager and you grab the 10th item. You say, okay, that looks okay. Then you grab the 20th item and you're like, oh, that kind of looks like a defect. Then you grab the 30th item and it's looking more defective, right? And I could say, oh gosh, what's happening to the machine? Not rhetorical. What's happening to the machine?
It's not functioning.
Right, it's starting to break down. And so this, all right, is a very common sampling approach, all right, most often used because we sample a lot of items, not just always people. And this is very often used with items, but can still be done with people as well. All right, so those are the 4 or 5 good sampling methods. The bad sampling methods, all right? And so the good sampling methods, unbiased. That's what we're looking for. Unbiased type sampling. However, bad sampling or biased sampling, all right, has become much more common. The biggest one is known as voluntary response sampling. Voluntary response sampling, and I guarantee you probably participated in one of these. On your social media feed, some poll comes out and asks you some question. All right. Basically, the concept is they're not checking who's referring to this. People are just like, oh yeah, no, I like this, or I dislike this, or whatever the question is. All right, you respond. The thing is that a lot of people, and especially the more complicated the question, maybe they don't know about it, so they don't respond. Usually those with strong opinions for or against are the ones who respond to voluntary response sampling. And that's the problem with it. All right. You basically miss everyone in the middle. And this is super common. What's upcoming November 2024? Election time. That is the Graceland of statistics. Okay. So election time, this is the big thing. And you see it way too often in election time that they send out these surveys, but they miss the middle. The middle is always what decides an election, all right? It's not the ones strong to the left or strong to the right. It's the people in the middle, because those people, all right, know exactly what they are going to vote for. The people in the middle, all right, are the ones that decide everything. And that's the problem with this sampling technique. The other one is really known as convenience sampling. And this one is really about laziness upon the sampler. So basically, I'm like, okay, I want to sample Gillette College students and ask them their work schedule. So I stand outside the college, but Friday between 12 p.m. and 5 p.m. and I sample everyone who comes in, asking them their work schedule. All right, and then I'm done and I go and I start analyzing my data. What's the problem with that?
You missed anyone who couldn't make that period.
Yeah, and maybe specifically anyone who works Friday. All right, a lot of students tend to work Friday through Sunday because, right, you have classes Monday to Thursday, and then that's a good time to work. So convenience sampling, and that's a big one that people just get too lazy as the sampler. And so it's all about, oh, I need to vary my sampling times. I need to go out at multiple times. I need to collect data. All right, dependent upon what I'm looking for, I need to think about that in my sampling process. So convenience sampling, very, very bad sampling. Both those types of samplings, voluntary response and convenience sampling, suffer from the same problem. Under coverage, all right, which is basically a type of non-response bias. All right, it's basically about missing a group, all right, of people, whether you had a bad sampling frame initially, all right, or you just didn't collect the group you were looking for. And so we always have to just watch out, make sure that we have a good sampling frame and we've varied our response times, or you're really good at following up, all right? Because internet surveys have become more and more popular, but the problem is you don't just run the survey and then stop. You have a demographic, you have to select who you're sampling, and then you pester them relentlessly until they respond. And that's how actually good sampling is. People hate it, but that's what good data result, that's how you get good results.
So an example of that, for just off the top of my head, I can think of sort of how YouTube has in their ads for videos, sometimes it's kind of like a listed survey of different sports events or types of channels that people watch constantly. That's 30 seconds per skip it, 15 seconds people skip it. Is that an example of it?
Kind of, except that is sometimes tailored specifically to you. It's kind of like Amazon, because if you're logged in, all right, to your Google account when you're watching YouTube, that's micro advertising. So they're getting that directly to you. All right. If you're not logged in, then yes. All right. But it's the same thing. When you log into Amazon, you purchase something and then it shows, oh, similar people bought, right? They're micro advertising to you. And advertisers have taken statistics to just the whole next level, right? The other big way, and again, election time coming up, this is a big thing. Response bias, aka known as bad wording. This is also most commonly known as push pulling. All right. When you are asked a question, all right, but given some preface information first. So given that, given 18-year-olds can be drafted, go off to war and die for their country and are legally allowed to buy guns, shouldn't we lower the drinking age to 18 as well? What answer am I trying to get out of you there? Yes. However, given that the highest, all right, alcohol accident incident rate is 21 to 24-year-olds, that is fresh drinkers, all right, and they have been driving already for 5 years at that point, do we want to lower that number to 18, so people have only been driving for 2 years or maybe 0 years, and add alcohol into that? What response am I trying to get from you there? And so obviously the question should just be, should the drinking age be lowered to 18? Or should the drinking age, lowered even has a little bit of connotation, should the drinking age be changed from 21 to 18? All right. So you want to try and ask the questions in the least influential way, all right, avoiding your own personal opinions. Election time, they are just classic. I love these questions. I can't see a question out there that is not push pulling, because they start with like a half-hour monologue before they ask the question, right? Again, it's statistician's paradise around election time. And so here's some other examples of bad wording. Just as a note, before you think all is lost, all right, as I started the class with, Gallup poll is the largest statistical consulting firm, all right, in the nation. Every time a sample comes out with some weird results, all right, they redo it and either confirm it or usually disprove it, all right? And so if you ever see something that says Gallup poll, you can trust that source.